In the next few problems, we're going to look at how to solve an equation, and it's going to help re-emphasize why it is so important for us to always check our work. So let's start with 415a. I'm being asked to solve the equation, the square root of the quantity 2x plus 3 is equal to x. Now, I don't know about you, but that square root's kind of getting in my way right now. So I'm going to go ahead and undo that by squaring both sides. When I do that, I'll get 2x plus 3 is equal to x squared. Now, I'm noticing that I could have a quadratic here if I go ahead and get everything on one side. So I'm going to subtract 2x and 3 from both sides to get 0 is equal to x squared minus 2x minus 3. Now, I'm trying to solve a quadratic, and I love to factor, and I'm thinking this is going to be factorable. So, got x and x, 3 and 1, and since it's a minus 2, I'll do a minus here and a plus 1. Okay. Now, I'm able to solve by setting each of these equal to 0 and solving for x. So here, I'll add 3 to both sides to get x is equal to 3. Over here, I'll subtract 1 from both sides to get x is equal to negative 1. So right now, it looks like I have two solutions. Now, in part B, it's asking us to think about the graphs of the two functions that we set equal to each other. Y equals the square root of the quantity 2x plus 3, and y equals x. So it's asking how many solutions each one has, and the answer to that would be infinite. The linear function is going to continue in both directions, both to positive infinity and negative infinity. And the square root function, though it's only going to grow towards positive infinity, it will still have infinitely possible solutions. Now, the next part, it's saying that Miranda's going to graph the functions, which is always a fantastic strategy. I know I'm a visual learner, and it helps me to see those things in action. Graphing helps to find the solution because if we can figure out where those two functions intersect, then we can see those solutions, and it will help us check our work. So then, if you go ahead and graph the two functions, Miranda's thinking that there's something wrong, and she's wondering what happens. So let's go ahead and graph that right now. Pause the video, try and graph them on your calculator, and see if you can see what the problem may be. So here I've graphed both equations. I've got y equals x in red and y equals the square root of 2x plus 3 in blue. And I'm seeing the problem here. When I look at this, it's only intersecting in one point, and yet I have two solutions. So what is the problem? So here in 416, I'm being introduced to a new vocabulary term. It says when a result from an equation solving process does not make the original equation true, it's called an extraneous solution. So it's not actually a solution, even though it is a result that you get when you solve it algebraically. So if we go back to the problem we did before, we have x equals the square root of 2x plus 3. I got the two solutions, x equals negative 1 and x equals 3. So let's check them right now. If I put negative 1 in for x, I'll get negative 1 is equal to 2 times negative 1 plus 3. Simplifying, I'll get negative 2, the square root of negative 2 plus 3. Simplifying again, that's going to be 1. So I end up with negative 1 is equal to 1, which that's not true. Okay, so that must be my extraneous solution. Let's check the other one to make sure that works out. So I'll put 3 in for x. So 3 equals the square root of 2 times 3 plus 3. So that's going to give me 6 plus 3 and 9. Oh, so now I'm getting something that makes sense. Square root of 9 can be 3. Okay, so here we go. So to summarize, I have one solution that actually works and one that is an extraneous solution. So in 417, it's reminding us that this is really re-emphasizing how important it is for us to check our work. Because sometimes we might get a solution that works algebraically, but it's not actually a solution to the problem. So looking back at the graph, it's asking us to look and see where that solution might appear. So x equals -1. So when x is -1, it looks like that would be right there. And when I'm thinking about it, it seems like that might be what would have happened if we had a symmetric function that we were working with there that also went into the negative numbers. But here's the problem. We're working with a square root function, and we can only take the square root of something that's positive, and our output, or I should say 0 or positive, and our output is going to be anything 0 or greater. So that means that we get this graph that is only from when y is 0 and greater. Therefore, this part of the graph doesn't exist, and that's why x equals -1 is an extraneous solution.